Hello everyone, my name is Anushri, second year BE in Information Science and Engineering student at Sri Venkateshwara College of Engineering, Bengaluru. Today's topic of my presentation is Tower of Hanoi. Agenda: History, Introduction, Algorithm, Iterative Solution, Recursive Pseudocode, Recursive Implementation in C, Analysis of Recursion, Pictorial Representation of how it works. History. The Tower of Hanoi, commonly also known as Towers of Hanoi, is a puzzle invented by E. Lucas in 1883. It is also known as Tower of Brahma puzzle and has appeared as an intelligent test for apes in the film Rise of Planet of Apes 2011 under the name Lucas Tower. Introduction. Tower of Hanoi is a mathematical puzzle where we have 3 rods and end disk. The objective of the puzzle is to move the entire stack to another rod, obeying the following simple rules. Only one disk can be moved at a time. Each move consists of taking the upper disk from one of the stack and placing it on the top of another stack, i.e., a disk can only move if it is the uppermost disk on the stack. No disk can be placed on the top of a smaller disk. Algorithm. Move the top n-1 disk from source to auxiliary tower, which means we are moving the n-1 disk from source to temporary, that is auxiliary tower. Move the nth disk, the larger disk, from the source to destination tower directly. Move the n-1 disk from auxiliary tower to the destination tower. That means the n-1 disk from the temporary tower is moving to the destination tower. Transferring the top n-1 disk from the source to auxiliary tower can again be a thought of a fresh problem and can be solved in the same manner. Once we solve the Tower of Hanoi with 3 disks, we can also solve it with any number of disks with the above algorithm. Iterative solution. A simple solution for the toy puzzle is to alternate moves between the smallest piece and the non-smallest piece. When moving the smallest piece, always move it to the next position in the same direction, to the right if the starting number of the pieces is even, or to the left if the starting number of the pieces is odd. If there is no tower position in the chosen direction, move the piece of the opposite end, but then continue to move it in the correct direction. Simpler statement of iterative solution. For an even number of disks, make the legal move between pegs A and B in either direction. Make the legal move between the pegs A and C in the either direction. Then make the legal move between pegs B and C in either direction. Repeat until complete. For an odd number of disks, make the legal move between the pegs A and C in either direction. Make the legal move between the pegs A and B in either direction. Make the legal move between the pegs B and C in either direction. Repeat until complete. So you can observe the difference between the even number of disks and the odd number of disks. In the second step, moving the pegs between A and C in even number of disks, and in odd number of disks, moving the pegs between A and B. Pseudocode. So the function name is TOH and N is the number of disks. X, Y, Z are the rods or stands, which is source, temporary, and destination. If N is greater than or equal to 1, which means we have one or more than one disk, put the n-1 disk to Z by using Y. We call the recursive function TOH again with n-1 disks X, Z, and Y. And then move the larger disk to the right place. Directly move X disk to the Y. Put n-1 disk to the right place. That is, we again recursively call TOH function with n-1 disks Z, Y, and X. Recursive implementation in C. Here the function name is Hanoi. Int disk, that is the data type of the disks are integer. and the character SRC, that is source, character destination, that is dest, and then character temporary is temp. If disks is more than 0, that is 1 or more, then Hanoi disks and -1 source temporary to destination. Here we put the disks from source to the temporary using destination, and then we put the disks from temporary to destination using this source. Here we have the int main function which calls the Hanoi function with 3 number of disks. The output will be move the disk from A to C first, and then move the disk from A to B, move the disk from C to B, and then move the disk from A to C, then B to A, then B to C, and from A to C finally. Analysis of recursion. Recursive equation is T of n is equals to 2T of n minus 1 plus 1. As we already see here, we have the n minus 1 disk call will be the twice, which is Hanoi disk minus 1 source temporary destination, and the second one is Hanoi disk minus 1 temp destination source. So we have 2T n minus 1 and 1 move for the larger disk from directly from the source to the destination. Solving it by back substitution, we have substituting n is equals to n minus 1. We have T of n minus 1 is equals to 2T n minus 2 plus 1. Then we are substitute n is equals to n minus 2. So T of n minus 2 is equals to 2T n minus 3 plus 1. Put the value of T of n minus 2 in the equation 2 with the help of equation 3. Then that is T of n minus 1 is equals to twice of 2T n minus 3 plus 1 plus 1. And then put the value of T of n minus 1 in equation 1 with the help of equation 4. We have T of n is equals to twice of 2T n minus 3 plus 1 plus 1 plus 1. T of n is equals to 2 to the power of 3, T of n minus 3 plus 2 to the power of 2 plus 2 to the power of 1 plus 2 plus 1. After generalization, that is up to k terms, T of n is equals to 2 to the power of k, T of n minus k plus 2 to the power of k of n minus k minus 1 plus 2 to the power of k minus 2 plus 2 to the power of 2 plus 2 to the power of 1 plus 1. Base condition, we know that for moving one disk, we require one move. That is T of 1 is equals to 1, that n minus k is equals to 1, k is equals to n minus 1, put k is equals to n minus 1. Then T of n is equals to 2 to the power of n minus 1, T of 1 plus 2 to the power of n minus 2 plus, it continues till 2 to the power of 2 plus 2 to the power of 1 plus 1. It is GP series and the sum is 2 to the power of n minus 1. Then T of n is equals to big O of 2 to the power of n minus 1, or you can say big O of 2 to the power of n, which is exponential. So for 5 disks, i.e. n is equals to 5, it will take 2 to the power of 5 minus 1, that is 31 moves. Pictorial representation of how Tower of Hanoi works. Let's see the below example where we have 3 disks that have to move in a destination, which is middle one with the help of an auxiliary tower. So then first we will move the disk 1 from the tower source to tower destination. We have this picture, and then move the disk 2 from tower source to tower auxiliary. We have this picture. Moving the disk 1 from tower destination to tower auxiliary, that is temporary tower. We have this picture, and then moving the disk 3 from tower source to tower destination. We have this one. Then moving the disk 1 from tower auxiliary to tower source, we have this picture. Moving the disk 2 from tower auxiliary to tower destination, we have this picture. And then finally moving the disk 1 from the tower source to tower destination, we have this picture. So totally we require 7 moves to move the 3 disks from source to destination strand using auxiliary strand. So here is a hyperlink that you can refer to the animation video of 7 disks using the 5 strands. So that's all for this video. Thank you.